Hello everyone, my name is Dipesh Kumar and today I'll be giving a demonstration of running a k-means clustering algorithm on a Spark application written in Spark on a Cloudera Hadoop platform. So clustering algorithms are nothing but unsupervised learning methods which are used when there is no class root predicted but to bifurcate the instances of dataset into two or more clusters based on some similarity. K-means clustering is one such unsupervised learning method which is very popular. So before giving you a walkthrough of the code, let me first show you the dataset that we are using for this demonstration. So this is the image segmentation dataset. Here we have the random instances drawn from a database of 7 outdoor images, where each instance is a pixel and it has various attributes like hue, saturation, mean, region centroid column, region centroid row, etc. And also a classification column as we are trying to the dataset aims to classify each instance into the classes such as image, cement, grass, path, image. However, we'll be trying to use this dataset to bifurcate the instances into two or more clusters based on variety in the pixel properties. For this demonstration, I'll be using a Cloudera virtual machine. It comes along with the Hadoop and Spark environment pre-installed on it. It also comes with the Eclipse IDE installed, wherein we can write the code for our Spark application. So this is my Eclipse IDE. I have created a K-means project, which is a Maven project. I've created a Maven project as it makes it very easy to add all the dependent libraries. We add the libraries in the pom.xml file. So in the pom.xml file, we can see all the libraries that we have added. We can add the libraries via XML file as well. So here we can see that I have added the Spark core library, Hadoop Commons library, Spark MLlib library. MLlib is the machine learning library for Spark. It has all the machine learning algorithms. I'll be using the k-mean class from this library. I've also added the Scala library in this project, as we are using Scala for our Spark application. Before giving you the walkthrough of the code, let me first take you to the file browser and show you the input files. So this is Hue, which is the file browser for the Hadoop file system for Cloudera platform. Here under user Spark input file, I have my input files where segment challenge is the training dataset and test segment is the test dataset. So we can double click on it to view the content of the file. Now let's go back to the Scala code. So this is the Scala code to read data from Hadoop file system, create k-means model using the training dataset and predict clusters for the test dataset. So here we have created our Scala object under clustering.kmeans package. Here we have imported the Spark libraries and Spark machine learning libraries, which will be using this code. So we are using k-means and k-means model and vectors from the Spark machine learning libraries. We are also using Spark configuration and Spark context from the Spark library. So this Spark configuration object is used to define the properties for the Spark application. So we are setting the application name as training k-means, and we have used the local string to define that we will be running this application locally using the setMaster function. Next, we'll pass this configuration object as parameter to the Spark context constructor, which is used to create Spark context object. This object is used with a driver to access the cluster. So here we can see that the driver is using the Spark context object to read the text file from this path. We are reading the segment challenge.txt, which is our training dataset, and test segment.txt, which is our test dataset. So next, we are removing the header from the training dataset and storing the remaining rows in the variable rows. Next, we are splitting both the training and test dataset based on the delimiter comma. Next, we are mapping the splitted data to a case class CC1. Here we can see that the case class CC1 has fields which are nothing but the columns of the dataset. So we are mapping the splitted data to its corresponding column in this case class CC1. Next, we are converting the RDD to data frame. We are performing this conversion as we need to print the data over here, and data frames organize the data into columns and rows, hence it is better for printing. Next, we are converting the data frame back to RDD. So RDD is the resilient distributed dataset. It is a unique functionality of Scala as it allows in-memory partitioning and hence faster parallel computation across multiple nodes. We can also cache the RDD. The caching makes the application faster when it is run next time, as uh, as next time it will directly use the cached RDD instead of performing all the transformations on the input files. Next, we are creating the vectors from these RDDs. We define the parameters for the trained model here. We are defining cluster and the number of clusters to 3 and number of iterations to 20. We pass these as parameters to the trained function. So we also pass input the training dataset. This gives us the trained model. Next, we are using that compute cost function on the trained model and training dataset, which returns us the sum of squared errors, which we are printing over here. Next, we can also save the trained model in a folder using .save function, and here we are loading the trained model from the same path we specified earlier and storing the trained model in a model variable. Next, we are using the trained model to predict the cluster for the test dataset, and here we are converting the result into a data frame, and then we print this data frame using the .show function. So guys, you can see that there our code has run successfully. So these are the 3 clusters that were created using the training dataset. So you can see these. This is the first cluster, this is the second cluster, and this is the third cluster. These are enclosed in these square brackets. Next, as we go down, we can see this is the sum of squared errors, which was computed using the compute cost function. This should be as low as possible. And as we go down, in the end, we'll find the result of a prediction. Here there's a cluster assigned to each instance of the test dataset. So one says that the first instance has been assigned to the second cluster. 0 says that the that this instance is assigned to the first cluster, and there's some instance which is assigned to the second cluster as well. And we can also find our trained model in our file system. So here on the Cloudera, we can see that k-means output has been created. This is a trained model, and here we can find our trained model. So that's it for this tutorial. Thank you very much.